Hi, everyone. How are you? My name's Ryan, and I want to talk to you today about GraphQL. Quick show of hands here. Who's using GraphQL right now? That's a fair number of us. That's great. Anybody thinking about using GraphQL, want to start using it maybe? Great. Anybody here that thinks GraphQL sucks? They hate it? Anybody at all? That's good. That's encouraging. That's really good to see. My name is Ryan Chenkie. I'm an Angular and Node consultant, so I work a lot with Angular and Node. I create applications for companies, kind of go in and help to solve business problems with new technology. I'm a Google developer expert, and I teach at angularcast.io. So if anybody here is doing Angular and you're looking for some courses on Angular, I'd encourage you to check out AngularCast. So GraphQL is everywhere, is what I would say. And it's not hard to see that that's the case when we see that there's all these well-known companies who are making use of it. I'm sure we're all pretty familiar with these logos. So GraphQL is really on the rise. And aside from just these big-name logos that are using GraphQL these days, the numbers also show us a trend that there's a lot of adoption happening. So this is the downloads per day from NPM for GraphQL.js, which I would argue is probably the most widely used GraphQL implementation out there. It's not the only one. There's, GraphQL is not tied to JavaScript in any way, but it's probably the most widely used one. And so we're reaching, middle of 2015 to now, we're reaching almost 200,000 downloads per day. So it's starting to climb quite a bit. And I mean, what's not to like, right? You can take a simple structure like this on the left to represent some data that you want, and you can get back the data kind of mapping exactly to that shape. And then if you have, so maybe that's for one client application, and then maybe if you've got another one that needs data from the same data source, but just a little bit less, it's very easy to take just a subset of that query and ask for exactly what you want. So it's very compelling. GraphQL is a very compelling technology to be using, which is probably why a lot of you are using it. Now, you get using GraphQL, it's in production, you've been using it for a while, and eventually the excitement about it kind of starts to fade a bit in a lot of cases. Hopefully not, but that initial kind of nice feeling you get with GraphQL can start to fade, and oftentimes that's because of some of the bottlenecks we can hit performance-wise with GraphQL. Now, the thing is, GraphQL is early, if we think about it. Facebook kind of came out with it back in 2012. So 6 years ago, in technology terms, that's a pretty long time ago. But it wasn't until 2015 that the spec was released. So we're talking only 3 years ago that the GraphQL spec was first released. And it wasn't until last year that GraphQL.js passed a daily download mark of 50K downloads. Here we are today. So really, there's not a whole lot of time that has passed here since it's been released. And so the point here is that GraphQL hasn't had the time for people to realize all of these all these bottlenecks, all these performance issues that you could hit in production and come up with solutions to them. With things like REST, we've had much more time to experience the pain that we can get out in the wild with large-scale applications, and people have come up with solutions to that. So the question is, what can we do to optimize GraphQL? What are some of the issues, and what can we do, even though it's still early, even though it hasn't been out in the wild for a long time? Well, there are some things we can do, and that's what I'd like to take you through today. One caveat first, though, is I'd like everybody to maybe just take in this quote and maybe just consider this for a second. So this is an author, Donald Knuth, said, "Premature optimization is the root of all evil." And so what I would encourage you to consider is that maybe it's not the best thing to go and take all of these suggestions and go try to code against them immediately, because you can spend a lot of time micro-optimizing without getting really strong results. So I would say, do what you want, but ultimately it might be better to wait until you feel some pain in production before you put optimization strategies in place. With that said, let's talk about the first way that you might optimize your GraphQL app. So let's talk about query batching. So here is a pretty typical looking application. A lot of applications will have some kind of dashboard. And maybe you've got 3 or more content areas. And with a REST API, you might furnish the data for these content areas from 3 different endpoints. So you've got a customer's endpoint maybe, then some kind of totals endpoint, and a jobs endpoint. And these are 3 parallel requests that are going to go to your API in the REST scenario. Now, if we look at this, if we're doing GraphQL, typically, if we have things set up kind of out of the box, if you will, that's going to be 3 different GraphQL queries. And in the same way that we did 3 parallel requests to our REST API, this is kind of 3 parallel requests to our GraphQL API. So what would be good is if we could take these queries and batch them up to only send 1 single request to our GraphQL endpoint. And that might look like this. This is kind of one way to do it. I know it's a little bit tough to see with a split in the screen, but essentially what we've done is we've just started to group all these queries together. So you can group as many different query fields as you want into a single query operation, and you might be able to get all of your data this way. And if we run into issues with namespacing, if we're trying to request the same resource but multiple times, we can use a feature of GraphQL called aliasing, which is where we give an alias to one of our fields so that we can pull out the same resource multiple times. So this would just send 1 single request to the API. However, grouped queries like this do have some problems. The first problem is that all queries need to finish. They all need to complete before we get anything back at all. So before we get any kind of result back from our API, everything that we've requested has to finish. And maybe one of the bigger ones, especially for the, I'm assuming a lot of people are using React, is that you can't really co-locate easily your components with your queries. And that's, if you're using React and GraphQL, you probably know that that's encouraged. You want to have your queries live with your components. Like in this example, you've got your component definition, and then you've got your query right under it. And so it's difficult to do this with typical grouping. If you're using Apollo Client, though, you can start to batch up your queries in an intelligent way. And it's actually very simple to do. If you're using the client, you can just set should batch to true. And that's going to turn on this batching feature of Apollo, where what happens is you've got 10 millisecond slices. And every 10 milliseconds, Apollo is going to look for outgoing queries. And if it gets an outgoing query, it's going to wait until that 10 millisecond frame finishes, and then it will send the request. So what this means is that, say in the next 10 millisecond frame, we might have 2 queries that need to go out. They're going to wait, Apollo's going to wait before sending that request, and it's going to batch those together. And so time goes on, maybe the next 10 millisecond frame is just 1, and then maybe you've got multiple in the next one. So one caveat here, though, is batching like this is only as fast as the slowest query. So every 10 milliseconds, you might have multiple queries going out, but if one of them takes a long time to resolve, well, you're going to get back to some issues getting your data back. It might be slow to get back. So I'd say don't be tempted to batch too early, but it can be effective at giving you a performance boost. The next thing I'd like to talk about is something called automatic persisted queries. So when you make a query with GraphQL, we've got that nice structure, gives us a representation of the data we want. When it ends up going to your server, this is kind of what it looks like. You've got the string representation of that query. And if you've got a larger query, well, that thing's going to grow. And it's going to grow. And it's going to grow. It's going to get very, very big. They've seen some really huge query strings out in the wild. This is a scale representation of, I think, the longest one that's been seen out in production. It cut right down the middle where that query string was. But there's a query string right in the middle here, going from Earth to the moon. And it's kind of to scale. It's plus or minus 100 meters. Anyway, point is, they've seen some really, really big query strings out in the wild. The thing is, the larger your query string, the slower the network request is going to be. And this is actually a big bottleneck, the network request layer. The larger your query string at this level, the more of a performance hit you're going to take. And this is significant. Like they've seen 10 kilobyte request strings out in the wild. And that's huge compared to the couple bytes we would get with a REST query. So what do? Well, one thing we can do, it would be nice if we could, instead of this long query string, if we could represent it with something like this, which is just the SHA-256 hash. So down here below is the exact same thing as you see up top, just run through SHA-256. And this is what automatic persisted queries gives us. So here's how it looks. You got your browser that's going to send a request to your server. If you turn this feature on, what you're going to get is the browser is going to send, optimistically, that hash to the server. And if the server knows about it, that's great. It's going to just send back, it's going to resolve the query that's represented by that hash immediately. But let's say it doesn't know about it. So what's going to happen is the server is going to send back to the client that it doesn't know about it. And then the client says, OK, well, in that case, I'll send you the full query string. And it only needs to send the full query string once. Once it gets to the server is going to cache it, it's going to know about it, and then it's going to be able to resolve that same hash in the future. So this is great because quite often in your application, you're going to have the same queries being sent over and over again. And if they're huge, well, you can save a lot of time in that network layer by putting in a hash instead of the full string. How do you use it? I wish I could show you. I was going to edit on the fly, but I probably shouldn't. This says, npm install Apollo link persisted queries. So if you want to check it out, Apollo's got a library that will allow you to use it easily. Here's what it looks like. It's very easy to use. When you're creating your client, you generally create a link when you're creating your Apollo client. When you're using persisted queries, you call for create persisted query link. You use that as your link that you pass to your client. And then on the server side, if you're using Apollo Server, it's super easy as well. Apollo Server gives us a lot of kind of out-of-the-box features like this that we can use. And the way that it works is it uses memcache from the back end. And if you pass some configuration to the persisted queries property here in your Apollo Server definition, you're just going to get this thing syncing up out of the box. So that's very nice. Now, this ties in nicely with something that comes from Apollo. Oops, go back here. I went way ahead. This ties in very nicely with Apollo Engine. Apollo Engine is this tool. It's a service that comes from Apollo that gives you a lot of nice things. So what it gives you is stuff like you can handle your automatic persistent queries much more easily. You can track errors, do tracing, all this kind of stuff. So if you use tools for errors like maybe Sentry, this is a good way to do additional tracking that's more particular to GraphQL. It runs on your own instance, so you would deploy it to EC2 or Kubernetes, and it's free to get started with, so I'd recommend checking it out if you're interested. It's very easy to set up on your server as well. You just provide your API key, and then you've got data syncing back and forth between Apollo Engine and your app. OK, so automatic persistent queries, really nice feature. Another one that I like to talk about that is a bit more advanced would be thinking about how to make our resolvers more smart, more adaptable. And so let's think about this for a second. Generally, when we have a query, every field that exists in the query has a resolver that it attaches to. And that needs to be run to get some data, say, out of our database and back to the client. So every field's got a resolver, and that means that if you have a big query like this, you've got to run multiple resolvers on your server, and potentially you have to wait a long time for any of those resolvers to complete. And it gets worse when you start nesting. We don't really know quite often as client developers what's happening at the resolver level and what might be creating bottlenecks, what might be causing slowdowns. We don't know, for instance, if maybe the resolver is fetching too much data itself that we don't actually need for the client. So here's a resolver, there's another resolver. There's a lot of them that need to run. And this ties into the n+1 query problem. Anybody familiar with the n+1 query problem? So what that says is this. Let's say we've got maybe two tables, thinking about like a relational database. We've got two tables. We want to take some data from one and tie it together with data from another. So we might say something like, give me all the posts for author with a certain ID. And maybe the query looks like this. Select a couple fields from that table where the author ID equals the ID. And then we might say, give me all the comments for all those posts, right? So what happens there is we'd have to do something like this. We'd have to say, let's iterate through all of those posts that came back, and for each of them, let's go fetch the comments based on that ID. So you've got one query up at the top, and let's say that returns 100 results. Well, then you've got to run 100 queries for that second one down below. So you've got n, which is 1, plus 100, because there were 100 results, 100 more queries, you've got 101 queries to deal with. And that's super slow. So we can optimize things here, and we can kind of make assumptions in our resolvers about how we might like to optimize. But ultimately, that can make our API a little bit less flexible, a little bit less usable, especially if we want to have maybe a public GraphQL API. So it can be a little bit difficult to make big assumptions about how the API and the database should tie together if we want to be super flexible. Makes it hard for having a high-performance API. So I was talking to Tan Mei. He runs a company called Hasura. Hasura basically gives you instant GraphQL APIs on top of a Postgres database. So if you have a Postgres database, you can just run Hasura on it, and immediately you can query it with GraphQL pretty easily. So he was saying, they ran into this problem. They found, because they have users who want to query tables with billions of rows, that it was difficult to be able to make GraphQL queries efficient for getting data out of their Postgres databases. So they use some libraries like Data Loader. There's a library called Data Loader by Facebook, I believe, that helps with caching and batching. But he said that wasn't super effective. And then he said, what if we can turn our GraphQL query itself into raw SQL and use that to fetch data from our database? And that's what they did. So here's how it works. Hasura will take the GraphQL query that you send to the API, and it will run it through an AST. So when you send a query to the server, you're going to get an abstract syntax tree. It's basically got everything that's happening in the query in a way that you can parse and manipulate. And they take that, and they turn that into raw SQL. So this is awesome because the query that gets made maps exactly to the SQL command that is needed to fetch exactly that data. So there's no guessing at the resolver level. There's no kind of making assumptions about how your data should be fetched. It's a one-for-one mapping. The other benefit that they got here is that you can make use of database features that might otherwise be hard to make use of. So for example, one of the bottlenecks that they realized with Postgres in particular is it takes a long time to turn that result from the database into JSON. It's a bit of a bottleneck. They were taking a lot of time to complete that. But there's a feature of Postgres called JSON aggregation, which handles that in a more efficient way. And they wanted to make use of it. So with this kind of setup, they were able to make use of JSON aggregation right away. All right, so what else can we do? There's some kind of things that we can do to affect the numbers, but what else can we do? Well, I would say we can affect perceived performance as well. And this is a really important way to improve the overall performance of your app, even if it's just perceived. So query splitting is one method here. And what that is, basically, we said before that we can group our queries to make things more efficient. It might make sense in your application to actually, if you have a big query like this, to split it up into two separate queries. Because maybe part of your application that's above the fold, or maybe just is the main point of contact when somebody first logs in, maybe that's all that needs to be furnished immediately. So you could split up your queries, and you could make the initial one, and then you could wait some time later to make the second query. Another thing you can do is run what's called optimistic UI. So optimistic UI basically looks like this. If you have a mutation, a GraphQL mutation, where you're saving some data, it's nice to be able to hit the save button, and once that happens, immediately show the user the result on the screen. But not the result that comes back from your server, the result just operating on the initial data that they render, that they save, and that can be rendered immediately. So you render the result immediately, and then once the result comes back, the actual result comes back from the API, you render that. Now, of course, there's some caveats here. You've got to make sure that if there's some critical information that might be different once it comes back from the API than what the user initially sees, that you give them a heads up or do whatever you need to for the purposes of your application, but it's a good way to be able to improve the perceived performance. So if the user thinks the application is faster, oftentimes that's one of the most important aspects. All right, so just some final thoughts here before we wrap up. Again, don't optimize too early. I would say wait until you run into the pain of the bottlenecks you might encounter. Wait until you hit that pain first before you dive in with optimization. Expect things to change. So again, GraphQL is early on in its life. There's going to be changes coming. There's going to be methods that we use next year that are going to make this year's methods look silly. So expect that change, and don't be shy to make those changes if necessary. And the final thing would be to just go and experiment. I mean, again, there's not that same period of time that's gone by that allows us to have battle-tested and kind of well-thought-out solutions to all this stuff. So experiment, find what works for you. And that's all. So thanks very much. Happy to take any questions.
Thank you, Ryan. All right. I've got a few questions here. Can automated persistent queries be used with Redis instead of memcached?
So I think that with Apollo, I think they only support memcached right now. But I wouldn't be surprised if it's easy to swap in another store to use whatever you want. It might be something that you need to kind of extend the server with. But as far as I know, it's just memcached right now.
Good. Next one. Is the AST to SQL query code open source?
It is, well, I don't know if Asura's got any open source code out there. I was talking to Tanmay directly about this, but I would reach out to Tanmay. He is, what is his? I'll just find his handle really quickly here. I had it on the screen. Because he's a great guy to talk to about this stuff. So his handle is Tanmaigo on Twitter. So I know you can't see it, but it's Tanmaigo.
All right. Next one. How do you feel about using GraphQL for parts of an application? Some use cases are arguably still easier to cover with REST.
This is, this is true. Some are. One area that you'll see quite often where people will default to REST would be things like file uploads, for example. There's kind of more out-of-the-box solutions, perhaps, that make that doable with a typical REST scenario. However, it's very doable with GraphQL as well. I take the approach where I use a mix. Quite often, I'll use a mix of GraphQL and REST. Sometimes that's because I have to, right? If I'm using a service that only operates on a REST API, then I'll use REST for that. But sometimes with my own API, I'll create a mix, just depending on the scenario. So I like it. Some people are pretty stringent, though, and they like to just use GraphQL. But I personally would use both.
Right. Another question from Dude. Are there any open source alternatives for Apollo Engine? I'd like to use it, but my company don't allow it because of data privacy of our clients. Well,
so there are some other solutions out there. I can't think of the names off the top of my head. I really just use Apollo stuff. My advice in this scenario would be try to work on your employer. Try to tell them that it's all good to use Apollo. But there are other things out there. I don't think you'll find anything as fully featured, though. Apollo's got, they've got a massive amount of features that are super valuable. So if you can work on your company, that would be my advice.
All right, and last question. How about HTTP caching?
Yeah, so like if you're using things like Apollo Engine, they give you ways to cache really intelligently and easily. So you might want to look to Apollo Engine for that. There's also ways that you can kind of cache at the HTTP layer without it. There's some libraries out there to do that. So yeah, it's worth a shot as well, caching.
All right, fantastic. Let's give it up for Ryan.